Let's try to answer this question. The car went on to travel at a constant velocity of 10 meter per second in a half a minute, then decelerated constantly for 30 seconds until it stopped. What is the distance covered by the car? So we're looking for the total distance covered by the car. So how are we going to solve for this kind of problem? First, we have here the given. The car went to travel at constant velocity in a half a minute. So let's compute for the distance travel by the car over half a minute, or the car travel at constant velocity in a half a minute. So we have here the constant velocity given, which is 10 meter per second, and the time, which is half a minute. When half a minute, 1 minute is 60 seconds, so half of it is 30 seconds. Now, let's compute first for the distance travel by the car in 30 seconds. Since it's constant velocity, so in order to find for the distance, we just simply use the equation b is equal to d over t. Since velocity is given, we have 10 meter per seconds equals d, the one that we're looking for, over 30 seconds. So let's compute for the distance. Let's multiply 30 both sides. When you multiply 30 both side, 30 seconds here, 30 seconds here, we will cancel this and this. What happen is we will have now 30 seconds times 10 meter per seconds is equal to D. Now let's multiply 30 times 10. We have 300. Cancel the seconds. We have 300 meter equals D. So this is now the distance covered by the car. We are not done yet. Okay, we are not done yet because base here, then decelerated constantly for 30 seconds. So we need to find the distance by the car at the next 30 seconds. So we have here now the distance for the first 30 seconds. So we need to find for the next 30 seconds. So here, the given for the next 30 seconds is the initial velocity. This is the given for the second. Given for next 30 seconds. Okay, we have the initial velocity, which is 10. And base here, then decelerated until it stopped. So when it stopped, the final velocity now is 0 meter per seconds. And we have a given time, which is 30 seconds. Oh no. How are we going to solve for the distance with having this given? So as you can see here, we can use the kinematic equation to solve for the distance. Let's use the kinematic equation. Change in x is equal to b initial times t plus 1/2 at square. However, acceleration is not given. So before we use this equation to solve for the distance, we need to solve for the acceleration first. So let's solve for the acceleration. Acceleration is equal to change in b over change in t. If we expand change in b, we have final velocity minus initial velocity over the time, total time. So we have here 0 meter per seconds minus the initial velocity is 10 meter per seconds over the time, which is 30 seconds. So we have here 0 minus 10 is negative 10. meter per seconds over 30 seconds. So divide -10 divided by 30, we have negative 0.3. Okay, negative 0.3 meter per second square. Okay, so this is now the acceleration that we can substitute in this equation. So since we already have acceleration, we can now solve for the distance for the next 30 seconds. So let's rewrite the equation. X is equal to b initial times time plus 1/2 at squared. So let's substitute the values. The initial velocity is 10 meter per seconds times the value of time, which is 30 seconds, plus 1/2 times the value of acceleration, which is negative 0.3 meter per second square, times the value of time, which is 30 seconds, and we need to square it based on the equation. So 10 times 30, seconds is cancelled. So we have here 300 meter plus, okay, we have here 30, let's write 1/2 times negative 0.3 meter per second square. 30 seconds times 30 seconds is 900 second square. Let's multiply 1/2 times negative 0.3, then multiply the answer to 900. So let's solve. Let's rewrite 300 meter. Then let's compute for the value of this one. 1/2 times negative 0.3 times 900. The answer is negative 135 meter, since we're going to cancel the second square. Negative 135 meter. So we have your 300 meter minus 135 is 165 meters. So this is now the distance covered for the next 30 seconds. So the total distance covered by the car for 1 minute is, we need to add the distance covered for first 30 seconds and this distance covered for the next 30 seconds. So to compute for the D total, I'm going to use the area below, and I'm going to use the yellow color to show how to solve for the total distance. We have here 300 meter, the, the first distance cover for first 30 seconds, plus the next distance cover for the last 30 seconds, which is 165 meter. So we have here 300 plus 165 is equal to 465 meter. So this is the total distance covered by the car in 1 minute. So that is how are we going to solve for the total distance cover.